You know, for years, there's been this invisible speed limit holding AI back. Well, today, we're going to dive into FlashAttention-3, the absolute breakthrough technique that just completely shattered it. I know, that's a pretty bold statement, right? But seriously, for the longest time, a core piece of modern AI models had this built-in bottleneck. It was like a handbrake that was always on, limiting how big, how fast, and how capable these models could really become. Okay, so let's get into it. What was this fundamental barrier that was holding back the next generation of AI? Well, it all comes down to something called the attention mechanism. So, attention is basically the magic that lets a model understand context, how all the words in a long sentence actually relate to each other. But here's the massive catch. Its cost scales quadratically. That means as you feed a model more and more data, like a longer article, the work it has to do doesn't just grow, it explodes. And this right here is the brutal math of it all. If you want to analyze a document that's twice as long, it takes 4 times the compute power. Want to go 10 times longer? That's 100 times the work. You can see how this problem was making it almost impossible to process really big things, like entire books or high-resolution videos. And here's the real kicker. Even the previous state-of-the-art, which was FlashAttention-2, was wasting a staggering 65% of the potential of a top-of-the-line NVIDIA H100 GPU. Just think about that. A huge amount of that incredible power was just being left on the table, totally unused. So how do you fix that? So how in the world did they solve this massive problem? Well, let's break down the first two absolutely brilliant techniques that FlashAttention-3 uses to claw back all of that wasted performance. Okay, so the old way of doing things, a GPU would, move some data from its main memory to its super fast on-chip memory, do a calculation, and then wait. Then it would move the next chunk. Lots of waiting around. Warp specialization completely changes the game. It creates these specialized teams of workers. One team is only responsible for moving data, while another team is only responsible for doing the math. And this is the perfect way to think about it. Instead of one person running back and forth from the pantry to the stove, you have this perfectly coordinated kitchen. The sous chef is prepping the next set of ingredients while the head chef is busy cooking the current dish. There's just no downtime. Everything is always moving. Now, the second trick is something called asynchronous pipelining. The attention calculation has a few different steps. There is a really fast number crunching part called matrix multiplication, or GEM, and that's followed by a slightly slower organizing step called softmax. What FlashAttention-3 does is just genius. It cleverly overlaps these tasks. So while a slower calculation is finishing up for one block of data, the fast matrix multiplication for the next block of data is already starting. And that's the whole point, really. This overlap effectively hides the slowness of the slower parts. The GPU's super powerful computational units are never just sitting around waiting for something to do. It's a continuous, overlapping flow of calculations, squeezing every single last drop of performance out of the hardware. Okay, so what's really fascinating about this next part is how they found yet another way to basically double the speed of everything, but it came with a huge risk, potentially losing accuracy. This technique is called FP8 Quantization. The easiest way to think about it is like using a lower resolution image. You can store it and process it way faster, but you might lose some of those important details. In AI, using these smaller 8-bit numbers can literally double your computational speed, but if you're not super careful, you can completely destroy the model's accuracy. So to get around this, FlashAttention-3 uses 2 incredibly smart tricks. First, instead of applying one scaling factor to a huge chunk of data, it uses block quantization. It just breaks the data into smaller pieces and scales each one individually. This keeps all the local details intact. Second, it uses this clever mathematical trick called incoherent processing. Imagine you have one super bright, overwhelming color in a picture. This trick kind of subtly blends that bright color with its neighbors. That way, when you compress the image, that one spot doesn't create a big, ugly error. It just smooths out the extremes to prevent mistakes. So after all these amazing optimizations, the specialized workers, the overlapping pipelines, the super smart low-precision math, what does the performance actually look like? Well, let's take a look at the numbers because they are pretty wild. Remember that 65% of wasted potential we talked about? Well, FlashAttention-3 pushes the hardware utilization all the way up to 75%. I mean, that is a massive jump. It more than doubles the efficiency of the previous version. Almost all of that power that was being wasted is now being put to work. And when they use that clever FP8 technique, the peak performance is just staggering. It hits 1.2 petaflops per second. To put that in perspective, that is over a quadrillion, 1,000 trillion calculations every single second. It's just an immense amount of power being unlocked from a single chip. And this table right here, this tells the whole story. Just look at it. Standard attention can't even handle a sequence length of 16K. It just flat out runs out of memory. Now, FlashAttention-2 was a huge improvement for sure, but FlashAttention-3, even in its standard mode, is nearly twice as fast. And then you switch on FP8, and the performance just goes into another stratosphere. It more than triples the speed of its predecessor. It's incredible. These numbers are amazing, but they're not just numbers on a chart. What do they actually unlock for us in the real world? This is really why this matters so much. Well, it means that AI models can now have much, much longer context windows, so they can understand an entire book or a complex codebase all in one go. It means analyzing high-resolution video actually becomes practical. We can train massive new models in a fraction of the time, and we can deploy way more powerful AI in real-time applications. This isn't just about making the AI we have today faster. It's about enabling a whole new class of models that were simply impossible before. And what's just wild is how fast this has all happened. The first version only came out in 2022, and it was all about minimizing memory access. Version 2 came a year later, improving parallelism. And now, just one more year on, version 3 achieves this gigantic leap by truly deeply mastering the hardware. The pace of innovation here is just breathtaking. By basically solving the attention bottleneck, the entire game has changed. The main thing holding back model scale and speed has just been lifted. And that leaves us with a really fascinating question. With this massive barrier now removed, what new bottlenecks are going to emerge? And what incredible new capabilities will be built on this new foundation? The speed limit has been broken, and the race is officially on.